We've talked about radical signs. You've seen those before. It's not the first time you've seen them. We've had tests and quizzes where you've seen those. The last test, I think one of the questions, one of the answers, or a couple of the answers involved square root signs, right? So when you see this symbol here, it doesn't necessarily mean square root. Okay, and we're going to talk about that why today. So the parts of it. The parts. First part is the actual symbol. The actual symbol is called a radical sign or radical symbol. Okay? That's what it's called. The actual symbol itself. It's not division. A lot of people say, oh, it's division. No, it's not division. It works differently. Okay? The number on the inside. There is a number on the inside. The number on the inside is called it's on the board, it's called the radicand. Radicand. Okay? That's the number we're going to try to simplify today, whatever it is. Okay? The other important part is this little number here. Sometimes it's not there. Sometimes it's called the index or the root. Okay. The index or the root. So the index or the root tells us a couple things. Now, you're used to seeing it not be there, right? You're used to seeing it not be there. Well, if it's not there, if there is no number there, it's always a 2 because it means square root, right? Square root. So if the index is not written, it means it's a 2, square root. Okay, and we'll talk about why that is today and all of that stuff. Okay, the last part. The last part is the number in front. What is the number in front called? That's not a new word. It starts with a C. Coefficient. Good. You guys saw that on your last test. Coefficient. Coefficient. A coefficient is just the number in front or anything in front. Okay. Okay, so before we get started here, I want you to, phones away. You want 10 points off your next test? Put that phone away. Open up in your notebooks to where you're going to tape this in eventually. Open up in your notebooks to where you're going to tape this in eventually. Because we're going to write something in there before you tape it in. So whatever page you're going to tape this into, open up to that page, whether it's on the left or the right. It doesn't matter. Okay, whether it's on the left or the right, it doesn't matter. Just open up to the page. I want you to go to the margins. The margins. The margins are the left, the very left, or the very right. Pick a margin, left or right. We're going to write in both of them. We're going to write in both margins. So pick a margin. We're going to write in those. Okay? We're going to make a list. We're going to make 2 lists. We're going to make 2 lists in the margin. Wherever you're taping this in, go to that margin. That's where you're writing in right now. Okay? So we're going to make 2 lists. The first list is the numbers that used to be here. Right? The numbers that used to be here. What were they called? Close. They started with a P. Perfect squares. Yeah, perfect squares. Okay, they're not there anymore because I erased them when we took the benchmark, but let's write those numbers in because you're going to see a lot of these numbers today. So in one of the margins, left or right, doesn't matter, we're going to use both. You're going to write the perfect squares. So what was the first number on that list? It was a 1. Why was it a 1? Why was 1 the first number on that list? There you go, because 1 times itself made that 1, right? And what was the next number on the list? Because why was 4 the next number on the list? 2 times 2 equals 4. Good. The next number, 9, because 3 times 3 makes 9, right? The next one was 16, right? Because 4 times 4 makes 16. And then 25, because 5 times 5 makes 25. The next number was 36. The next number was 49. The next number was 64. The next number was 81. The next number is 100. We're not going to go very far. I think we stopped at 144. 13 times 13, 169, 169. That's as far as we went, I think. You can keep going forever and ever and ever, but I'm going to stop right there because I think that's as far as we went on our list. So the reason those are important, so my question is this. Why is the square root of 49 7? If you put all of you put in your calculator square root of 49, you'll get a 7 as an answer. And that's right. Why? Exactly, right? There's a pair of 7s that make up 49. Right? The reason why 81, the square root is 9, because there's a pair of 9s. Pair, right? I'm looking for 2. Square root means look for 2. It's pairs, okay? Okay, so in the other margin, I want you to do one for the perfect triples. Perfect triples. So instead of perfect squares, it's perfect triples because there's 3 of them. So what is the first perfect triple going to be? 1, you're right. 1 is going to be the first perfect triple. Why is it a perfect triple? There you go. So what's the next perfect triple going to be? Which is 8. Good. So 8 is the next perfect triple. 8 wasn't on our list earlier, right? It wasn't on the perfect squares list, but it's on the perfect triples list. What's the next one going to be? 3. 27 is the next number. What is the next number? 64. Good. 64. 64 is also on our perfect squares list, so it's both. We're not going to go too much further, but what would be the next number? And then I think we'll go one more. This one is 216. Okay, so those numbers are perfect triples because they have triples that make them up, right? Okay, 3 of a kind. So today we're going to be doing a lot of looking for pairs and looking for 3 of a kind. Okay, that's what we're going to be doing a lot of today. All right. Okay, so let's go back to the notes now. So the steps we're not going to worry about right now because we'll do the first one together and we'll do the steps together. Okay, so example number 1 at the bottom of the first page. 112. 112. Is 112, first of all, is this a square root or is this a third root? Yeah, how do we know it's 112 is a square root? There's no number, right? So if there's no number, it's a square root. That's a 2. Right? If there's no number, it's a 2, which means we're going to be looking for pairs. Right? And it's not on my list of perfect squares. It's not on my list. If it was on my list, easy. answer it and move on, but it's not. So what we're going to have to do, the first step is what we call prime factorization. It sounds a lot more difficult than it really is. You've done this before many, many times, probably in elementary school, where you did the number up here and then you figured out what multiplies to be that number. There you go. A lot of people call it a factor tree. With branches and stems, right? So what two numbers multiply to be 112? Any two numbers. Those of you with calculators in your hand, phones in your hand, put it to good use. What was it? 4 and 28. Okay. And then 4 breaks down to 2 times 2. 2. Each of those 2's. What does 2 break down to? What's the only way to make 2? 1 and 2, right? So when we get to that, we say we're done with those numbers and we circle them or box them or put a triangle around them. Something, I'm going to circle them in red to show that I'm done. I can't go any further because it's just 2 times 1. 28, though, we can still go. 28 is 7 times 4. And then 7 doesn't break down, right? So 7 I'm going to circle because it's just 7 times 1. 4 breaks down again to 2 times 2. Circle the 2's. It's important to circle them because you're going to rewrite. Now what I'm going to do over here with 112 is I'm going to rewrite it with those circled red numbers. So instead of 112, this is what I'm going to do. I'm going to say the square root of 2 times 2 times 2 times 2 times 7. I had 4 2's and a 7. Now, if I multiply 2 times 2 times 2 times 2 times 7, I'll get 112. So it's not like I changed 112. It's the same number. It's just not, looks different. Okay? It's a square root, right? So anytime I'm finding a square root, I need to find pairs. So let's circle the pairs. That's our next step. Circle any pairs. I got a pair there. I got a pair here. 7 doesn't have a pair, so I'm not going to circle it. Okay, so here now, what do the first 2 pairs make? When I multiply the first 2 pairs here, they make 4. Isn't 4 on my list of square roots? What's the square root of 4? So what I'm going to do here is I'm going to take this out because these 2 guys have a square root. Their square root is a 2. I'm going to cross out those because those have a square root.
1, 2, you mean 4 has a square root?
Yeah, it's 2. Okay, what about the next one? Yeah, the square root of 4, these 2 guys together is also 2. So I'm going to take out another 2 because that square root is 2. Cross those out. 7 doesn't get to leave because it doesn't have a pair, right? It's not 7 times 7. It's not 7 times 7. So if it's not that, it has to stay. So it's going to stay under the square root. Now I can multiply the 2 guys together here to make 4 times the square root of 7. That's my answer. I can't simplify it any further because 7's the only thing left, and that doesn't have a square root. It's not on my list. Okay, so before we go on to the next problem, I'm going to ask you some questions that I hear all the time. I've been doing this a long time, and I hear these questions all the time, so I want to talk about them. First question will be, Mr. Flores, you had 4 2's to begin with, right? I had 4 2's, but then 2 of them went away, and 2 of them went to the front. Why? What happened to the other 4? I had 4, right? But then 2 of them came out here. What happened to the other 2? Why didn't I bring out 4 2s? Close, you're getting there. Why didn't I have 4 2s on the outside? Didn't I have 4 2s on the inside? Why did only 2 of them get to come out? Because exactly, it took 2 of them to make a square root, right? They had to pair together to make a square root of 4. That's 2. And then these 2 had to pair together to make a square root 2 of 2 as well, right? Another way to think about it is, how many pairs did I cross out? How many came out? That's it. That's another way to think about it. However many pairs you crossed out, that's how many come out in the front. Okay? I know I'm going to get that. Right now, you guys are all like, yeah, that makes sense. But tomorrow, I know I'm going to have that question. You had 4 on the inside, but then 2 came out. What happened to the other 2? Right? So I want you to remember this tomorrow when I get that question. Okay? All right, so let's go look at another one. So I want you to do this one on your own. Do number 2 on your own. Number 2, square root 96. Still square root. Still looking for pairs. Okay, so I broke down 96, 2 times 2 times 2 times 2 times 3. There's 5 2s and a 3. Doesn't matter how you start. Some of you probably started 12 times 8. Some of you probably started 4 times 24. Doesn't matter how you start. At the end, you will get the same red numbers circled. Okay? Now we're looking for pairs. So circle the pairs. I have a pair of 2s, a pair of 2s. That's it. The other aren't a pair. 2 and 3 aren't a pair. So they got to stay. Okay? So what can come outside? Well, I have a pair of 2s here, a pair of 2s. Those pair of 2s make 4. What's the square root of 4? So I got a 2 on the outside, cross those out. Same thing over here. Pair of 2s. Those pair of 2s make 4 when you multiply. The square root of 4 is 2. Cross those out. On the inside, I have 2 times 3, which is just 6. Multiply the 2 in the front, the 2's in the front. I get 4 times the square root of 6. 3 and 2 had to stay because they didn't have pairs. Okay. So in the space in between number 2 and number 5, where the crease usually goes when you fold it, I want you to do one problem real quick. Square root 75. Square root 75. I want you to do that one real quick. What does the square root of 75 simplify to? 75 breaks down to either 25 and 3 or 15 and 5. Either one either one will work. So if you do 15 and 5, that's a 5 right there. 5 can't be broken down anymore. And then 5 and 3 can't be broken down anymore. So either way, 75 is 5 times 5 times 3. Square root, looking for pairs. I have one pair of 5s. 5 times 5 is 25. The square root of 25 is 5. 3 is left on the inside because that one doesn't have a pair. 5 times the square root of 3. Okay. All right, so now let's move on to number 3. Number 3. First thing you notice is the x's and the y's. Don't worry about that right now. We'll put that to the side. Don't worry about the x's. Do 54. 54, break down 54. X's and y's we'll deal with in a second. I want you to do 54. Break down 54 just like you did 96 and 75 and 112 before it. Okay, so what does 54 break down to? Yep. 3 3s and a 2. Now let's bring in the x's. What does x to the 6th mean? How do I break down x to the 6th power? So x to the 6th power. So x to the 6th power. How do I break that down? How do I make that 6? In other words, how do I make that 6 here? What did they do to make that 6? Not 6, x, right? That, right? That's what I'm going to put in here. I'm going to do it the long way, and then I'm going to see, and then we'll talk about it afterwards. I want to do one problem this way, and then 5 y's, right? That's what that means. Looking for pairs here. Circle the pairs. Okay. There's already an x out in front. That's how it started out. The problem started out that way. There was an x in the front, okay? So now, what else can move out to the front? Well, the first one is 3 times 3. What is 3 times 3? That's on my list, right? Right? That number is on my list, right? So the square root of that is 3. So I can have a 3 here. So I cross that out. How many pairs of x's do I have? 3. Good, right. So 3 can come out. So how do I write that on the outside? There you go. There you go. X to the third power. But I already have an x out there, so make sure you include that one there. And then how many y's can come out? Y squared, right? So what's left on the inside? 3 times 2, which is 6, and then y. Now you can combine anything you can combine here. So if I combine those, I get x to the fourth power. Where do you see 2 x's?
There's the x to the third power, then there's a plus xy2.
Where did that extra x come from? Look right above it, directly above it. It was already there. This guy just came down here. There was an x already. That's why I said there already was an x there. I didn't do anything to create that. That one was there from the very beginning. Okay. Okay, so next one. It's already got a y squared in the front. It's already there. Already there. 75, 750. Break down 750. If a number ends in 0, what number should you start dividing it by? 10. Start with 10. It's the easiest number to divide into. 750 breaks down to 75 times 10. Okay, so let's bring it back. So I have y squared already there. 750 is 3 5s and a 3 and a 2. And then I have x to the 10th, y to the 10th. So you're the first class that when I did the problem right before it and I wrote all the x's and the y's, you guys, I didn't hear anybody complaining. Every other class I've had has, oh man, we got to write all those out. We got to write all of those out. You might have been doing it. Hey, come on. You might have been doing it, but you were kind of doing it to yourself, right? I couldn't hear it. So let's look for a way so I don't have to write all of those x's, because I don't want to have to write 10 x's and then 10 y's. Now, I don't want to discourage you from doing it. It works. That the process works, but it's a lot of writing, right? So let's look for another process. So let's look for pairs first. Or am I looking for pairs here? I'm looking for triples. This is a triple situation. Triples. So I'm going to circle triples. I have triple 5s here. That's all my list of triples. 5 times 5 times 5? 125, right? What's the cube root of 125? So I'm going to write a 5 out in front with the y squared that's already there. Okay, 6 has to stay. 3 times 2 has to stay. Now, instead of writing x times x times x times x times x times x and y times y times y times y times y 10 times, can I do a shorthand way of doing it? How many triples am I going to have in x to the 10th? How many triples am I going to have? How many groups of 3 am I going to have with this guy here? 3, right? I'm going to have 3 groups. So I write that as x to the 3rd. Isn't there going to be 1 left over in there too? Yeah. Same thing with y, right? I have 3 groups of y, and then I have another xy left. So it's 6 xy that are left. Because there was 1 left over x, there was 1 left over y, and 3 times 2 makes 6. Now, down here on the outside, I have some things I can combine, right? I can go 5x to the 3rd, y to the 5th. Done. That's a shorthand way of doing it. You don't have to write out all the x's. Now, if it's easier for you to write them out, It takes an extra 15 seconds, right? That's all it takes to write all the x's, all the y's, and then circle triples. Do that, okay? If it helps, do that. I don't want you to not do it and then on the test get it wrong, okay? If it helps, do it. On the test, you're only probably going to have one of these questions that looks like this. That's one question, and it's the difference between getting it right and getting it wrong. Do it, okay? Do what's going to help you. All right. Okay. Let's look at number 5. What does the word product mean? Multiply. So we know we're going to multiply. What are we going to multiply? These two guys right here. Those two guys right there. Okay. So when you're multiplying, it's not that bad. You multiply the numbers in the front. 10 times 4. What do you get when you multiply 10 times 4? 40. So that's going to be 40 out in front. So this guy here, we multiply. And then since they're both square roots, you multiply these two guys together and you get the square root of 120. And then it turns into number 1 or number 2. Simplify, 120. We got to break down 120. Got a 0, multiply times 10. So 120 I get breaks down to 5 times 3 and then 3 2s. Circle the, which are we looking for here? Pairs or triples here? Pairs, good, pairs. So let's circle the pairs. I got a pair of 2s and that's about it. So 2 times 2 is 4. The square root of 4 is a 2. So I'm going to bring a 2 out here. So I have 40 times 2. Everything else stays. 5 times 3 times 2. So I get 80 out in front. And then 5 times 3 times 2 is 30. as far as you can break it down. Nothing else. I couldn't break it down any further because there was no other pairs in there. I was looking for pairs, couldn't find them. All right. Okay, last two. The next one is another multiplication except with all the words, without all the words. It's more like the multiplication you're used to seeing. We're going to do the same thing. We're going to do the exact same thing we did before. There's no numbers in front, so I don't have to multiply those numbers in front, but multiply the numbers. What's 108 times 4? 432. And then how many powers of D am I going to have? 10. Good, 10. Now do the problem like you did number 3 or 4. Number 4, I think it was. I'm looking for triples here. So I got to break down 432. Luckily, they told me what multiplies to be 432. 108 and 4. Then 108's 54 and 2. 54 is 9 and 6. And then 9 is 3 and 3. And then 6 is 3 times 2. So I got 3 3s and 4 2s. And then D to the 10th. Stop right there. What do I do next? Triples. So I got triple 3. Triple 3 is 27. Well, that's on my list. 27, the cube root of 27 is 3. Cross those out. 2 times 2 times 2, I got triple 2s. Triple 2s. That's 8. That's on my list. The cube root of 8 is 2. I have another 2 in there that can't come out because it doesn't have a triple. How many triples am I going to have with D to the 10th? 3 triples, and there's going to be one that has to stay, right? So I have 2, and then that's just going to be a D. Okay. So there were, let me write this down here. There were 3 triples in there. There were 3 triples in there. That's why I took out D to the 3rd. But there was one left over that had to stay. All right. Okay, one more in division. Division's just like multiplication. Okay, so instead of having 1, 2 division problems, top divided by bottom, first thing I'm gonna do is put them under the same, just like I did with multiplication. Put them together. Okay. Before I do pairs or triples or any of that stuff, I'm gonna do division first because it's actually easier to do division right now. So I'm gonna cut these into thirds. because the first two I can divide. So the first two is 9 goes into 180. How many times does 9 go into 180? Not 9. 20 times. Yep, 20 times. Good. And then in the middle here, in the middle I have x to the 9th over x to the 4th. Well, it's division. When I multiplied them, what did I do with the powers? Added them. So what do you think I'm going to do when I'm dividing? Subtract them. Subtract the powers. Okay. So now simplify it just like you did one of the other problems. So we got to break down 20. Breaking down 20 is not too bad. It's just 4 times 5 and then 2 times 2. So I have 2 times 2 times 5. Then I have x to the 5th and y to the 4th. Now I can circle triples, or sorry, doubles on this one. Doubles on this one. Right. Good question. How do we know if it's doubles or triples? Yep, right here. Right here. If it's not there, doubles always. If it is there, it's whatever number is in here. So we haven't seen any bigger than 3, but there could be a 4 or a 5. That just means we look for 4 of a kind or 5 of a kind. Whatever number is there, whatever number is here, that's what you're looking for. And if there is no number, always doubles. Always doubles. Good question. Okay. So 2 times 2 is 4. The square root of 4 is 2. Cross those out. 5 has to stay. But how many doubles are in x to the 5th? 2 doubles, right? 2 doubles. So x squared leaves 1 left behind, right? And then how many doubles are in y to the 4th? None left behind. So 5x is left in there. There are no y's on the inside because I took all of them. I used all of them. Okay, so good question. How do I know if it's doubles or triples? Always look here, the number there. If there is no number, it's doubles. If there is a number like there was for this guy here, that's what we're going to play with. Triples there. Okay, sometimes you'll see to the 4th power. That means you're looking for 4 of a kind, whatever it's there. Okay, all right, so tape it in. What's that? The chapter review? No, that was an assignment. That was tape those in.